In this video, we will discuss about different data types which we have in Apex. So let's start. So first of all, we will try to understand what is data type. As its name suggests, the type of data a variable will hold is defined by the associated data type with that variable. So the Apex language is strongly typed, so every variable in Apex will be declared with the specific data type. So for an example, if we want to store I equal to 5, then this I should be of data type integer. Okay, so we will just write integer. So now this I is of type integer and it can hold any integer value. So this is the data type. Okay, all Apex variables are initialized to null initially. For an example, if we have written like integer I, then the value of this particular I is equal to null. When we will write I equal to 1, then the value of I will be 1. Otherwise, the value of I will be null. So when we initialize a particular variable, so the value of that particular thing will be null. Okay, a bit off. Okay, so it is always recommended for a developer to make sure that proper values are assigned to the variables. Otherwise, such variables when used will throw null pointer exceptions or any unhandled exceptions. Because if you are doing, so for an example, we have integer I and you are doing some operation on this particular value I. So for an example, I plus 1. So the value of I is null, and null plus 1, it will not return the value which is expected. Then it will throw some exceptions. Okay, so that's why we have to be very specific. We have to do null checks whenever or wherever it is required in that particular while writing Apex code. So it's the best practice to do null check before doing any operation. So moving ahead, we have primitive data types. So first is ID, any valid 18 character Lightning Platform record ID identifier. So as we all know that there is 15 digit and 18 digit ID, and all the IDs which are there in the Salesforce for any record, there is a unique identifier to it, that is ID of that particular record, and it is the 18 digit ID. Integer, a 32-bit number that does not include a decimal point. So all the integers will be a whole number. It cannot include a decimal value to it. Like 1.0 or 1.1 cannot be there. It will be 1 only. Long, a 64-bit number that does not include a decimal point. Use this data type when you need a range of values wider than the range provided by the integer. So integer and log is same. It's just the range of values which we get to store in integer and which we get to store in log. Object as subject generic type or an as subject specific type such as account. All Apex data types inherit from object. You can cast an object that represents a more specific data type to its underlying data type. For example, object obj equal to 10, integer I equal to integer object. So we are just typecasting the object value as an integer. String, any set of characters surrounded by single quotes. For an example, string is equal to Salesforce. So if it is surrounded by this single quotes, then it's a string. Time, a value that indicates a particular time. Always create time values with a system static method. So there are some methods to its instance of and all that methods which we will talk about later on in this video. So next it's blob, a collection of binary data stored as a single object. You can convert this data type to string or from string using the toString and value of methods. So there are different methods to it. It's like when you want to convert anything from a string, or when you want to convert anything to string. So there are some different methods to it. Blobs are stored in a document or sentence and attachments. Boolean, as we all know, a value that can only be assigned true, false, or null. For an example, Boolean is winner equal to true. date, a value that indicates a particular day. You can add or subtract an integer value from a date value, returning a date value. Date time, a value that indicates a particular day and time, such as timestamp. So the created date of a particular record holds date and time of that record. If we use function date value, and then we can get only the date value from that particular date and time. Decimal, a number that indicates a decimal point. And double, so a 64 digit bit number that includes a decimal point. So integer and long, we cannot have a decimal point. In decimal and double, we can have a decimal point. Next, we have collections: list, set, map. So a list is an ordered collection of elements. A set is an unordered collection of elements that do not contain any duplicates. A map is a collection of key value pairs where each unique key maps to a single value. So we have a very dedicated video on collections in Apex or Salesforce. So the link is in the description. So next we have enums. An enum is an abstract data type which with values that each take on exactly one of a finite set of identifiers you can that you can specify. Enums are typically used to define a set of possible values that don't otherwise have a numerical order. So you can use enums when it is very deterministic and the values are, you are very sure about the values that will be there in that particular enum, which you will require in your code. Typical examples include the suite of card or a particular season of the year. For an example, we have public enum. The season can be winter, spring, summer, and fall. So season e equal to season dot winter. So the e will hold the value of this winter now. So season e, if season e equal to season dot summer. So season dot summer is summer, and e is holding value of winter. So winter is not equal to summer. So this system dot debug will print e. So that is winter. So the answer, so the result will be winter. Okay, so now this particular seasons are very deterministic and we are aware of that, so we can use a enum for that. Okay, so now moving ahead, we will talk about the different type of variables which we have in Salesforce or in Apex while writing Apex code, which we have to take care. So variables can be local variables are declared with Java style syntax. For example, string product name is equal to iPhone. So as you can see, we have used single quotes while writing iPhone. So it's a string. Data type, then integer I equal to 0. So this, the value of the I now is 0. If we will say integer I semicolon, then the value of I will be null. Set string, set of products equal to new string. Map of id and string, map of product id equal to map id and string. Okay, so this is a set, this is a map, this is a collection variables. So this is the variable name. So this is variable name. Okay, this is data type of that particular variable, and this is, we are just creating instance of that variables here. So for an example, set of string, so this variable is set of products, we are creating instance, so we can use in our code later on. Multiple variables can be declared and initialized in a single statement like this. If there are multiple variables you want to create for integer or string, you can create in this manner. Null variables, if variable is declared but didn't initialize it with a value, it will be null. Null means the absence of a value. You can also assign null to any variable declared with a primitive type. For example, both of these statements return in a variable set to null because we have declared this x as null and decimal d we have not initialized it. That's why the value of this d will be null. Okay, and we here we have initialized this value of x to null. That's why the value of x will be null. Initial values. All variables are initialized to null if they aren't assigned a value. For example, variable I and k are assigned values while the integer variable j, so we are talking about this variable j and the boolean variable b, so this is the boolean variable b, are set to null because they aren't explicitly initialized. So we have just declared some variables, and we have some variables we have initialized at the same time of declaration. So the value of I will be 0, k will be 1, and the value of j and k will be null because we have only initialized them. We have not declared them with a particular value. Variable scope. Variables can be defined at any point in a block and take on scope from that point forward. Subblocks can't redefine a variable name that has already been used in a parent block, but parallel blocks can reuse a variable name, for example. So in this example, we are creating integer I, this is a variable, and in the method, this is a methods, and in that also we are creating integer I. So this is not allowed because already this particular variable has been created and the name is same for the both the variables. So for an instance, we have a class, and in that class we have method AB. Okay, so just in AB we have for an example integer A. Then we have method ABC. In that also we have integer A. So this will work. This will not throw an issue or throw an error. But so this is the statement it mentioned, like, but parallel blocks can reuse a variable name. So that this variable name can be reused. So this both the both the variables have same name, same data type, but as they are in the different methods, so this can be used. But if in this C is the class name, and if I define integer A, and in AB method also I'm writing integer A, then it will throw an error. Okay, like this example. So this is regarding the variable scope. Case sensitivity. Apex is also case insensitive. This means variable and method names are case insensitive. For example, integer I means I can be small, can be means it can be uppercase, it can be lowercase, but it will have depict the same meaning, and it is case insensitive in Apex. References to object and field names are case insensitive. For example, account A1, account A2, whether you write in uppercase, whether you write in lowercase, it doesn't matter. SOQL and SOSL statements are case insensitive. For example, account select ID from account where name equal to Fred. So as you can see, some of the letters are in characters are in uppercase, some of the characters are in lowercase. Anyhow, then also we will get the exact result which we are looking for because it's a case insensitive. Moving ahead, we have constants. So as its name suggests, it will depict a constant value. Apex constants are variables whose value don't change after being initialized once. So when you initialize the value of that particular variable, so when you declare the variable value, you cannot change it. Constants can be defined using the final keyword. The final keyword means that the variable can be assigned at most once, either during declaration or with a method defined in a class. For example, it declares two constants. So for an example, we have declared a particular this variable const1, and in the same time we have initialized it with a value 200. Then we have declared one variable that is const2, and the value of this particular variable will get from this particular method, that is calculate method. Okay, this value can change because it's written 2 plus 7, and if we change it to 3 plus 7, the value will change accordingly. Okay. Important keywords: final, instance of, so the spelling is wrong, I think so, it is instance of this super. A final variable can only be assigned a value once, like in constant we have seen. Either when you declare a variable or inside a constructor, you must assign a value to it in one of these two places. To define a constant, mark a variable as both static and final. Methods and classes are final by default. You cannot use the final keyword in the declaration of a class or a method. Instance of, if you want to verify at the runtime whether an object is actually an instance of a particular class, use instance of keyword. The instance of keyword can only be used to verify if the target type in the expression on the right of the keyword is a viable alternative for the declared type of expression on the left. For an example, if reports.get the first location, the get zeroth location instance of custom report, then custom reports equal to custom report reports.get zero, what the value is. If it's a custom report, then it will typecast it. Otherwise, do something with the non-custom report, because that report will be non-custom, or it's not a custom report. The super keyword can be used by classes that are extended from virtual or abstract classes. By using super, you can override constructors and methods from the parent class. So for an example, we have a parent class that is super class. In this example, in this we have declared some strings like my salutation, my first name, my last name. Then we have called this particular constructor. In that we are declaring something. Then we have parameterized constructor, and in that also we are passing some values from it to that particular variables. Then we have method void print name. Now this particular class, this is a subclass. So this subclass is also using this same method. Okay, so this method is used by this subclass, and this subclass is extending superclass, this superclass. And we have used this public override void print name, so it will override the print name super dot print name. So now the functionality of this print name, when you are when you want that functionality to run from subclass, then it will have different logic to it. When it runs from superclass, it will have different logic to it. Okay, so you can use the same method name. You can if you want to override it, then you have to use a super keyword, and you have to use override word while defining that particular method in that extended class. Otherwise, you can use in the parent class in which it is defined. Then we have this keyword. There are two different ways of using this keyword. You can use this keyword in dot notation without parenthesis to represent the current instance of the class in which it appears. Use this form of this keyword to access instance variables and methods. For example, public class my test this string s, we have declared this dot s equal to test string. So s is an instance of that particular variable, that is s. So that's why we have used this dot s. This is the same name of that variable. You can use this keyword to do a constructor chaining, that is, in one constructor call another constructor. In this format, use this keyword with parentheses. For an example, we have test this class, then we have test this one constructor, and then we have another constructor. So this is a parameterized constructor. We are passing s2 as a string. In this we are having public test this. So this is a default constructor. It will run, and now it will pass the value this none. So the none will be passed in this, and now this constructor will run. So it's a chaining. When a class runs, first this constructor will run, and then this constructor will run. So that's all for variables. Thank you. Have a nice day.